Hey guys, so today we have a question on mechanics, specifically on momentum and impulse. Let's read the question. A car of mass 1000 kilos collides head-on with a truck of mass 2000 kilos. Both the vehicles are moving at a speed of 21 meter per second. The collision is perfectly inelastic. After the crash, the two vehicles skid to a halt. Assuming the friction is the only force acting on the vehicles after the collision, how much work is done by friction after the crash. So here we have two bodies, a body M1 of mass 1000 kilos, a body M2 of mass 2000 kilos. Now, they say that both the vehicles are moving at a speed of 21 meter per second and the collision is perfectly inelastic. Here, inelastic is a keyword which specifies that the momentum is conserved. The momentum is conserved during the collision, whereas energy is not conserved during this collision. This being said, we know that conservation of momentum from Newton's third law gives us the equation m1u1 plus m2u2 is equal to m1v1 plus m2v2. This is an equation we obtain from Newton's third law specifically after we assume that the force applied by the car on the truck is exactly equal to and in opposite direction to the force applied by the truck on the car. Let's write Newton's third law. So F12 is equal to negative of F21. And we both know that force F is nothing but change in momentum delta P by delta T, or mv minus mu divided by T, or delta T. With these substitutions, we end up with the conservation of momentum equation. Now let's write the equations. They say that both the vehicles are moving at the speed of 21 meter per second. And still, if they have a head-on collision, that should definitely mean that both of them are traveling in opposite directions. Now let's assume for ease, the car is traveling to the right, which means its initial velocity is positive, whereas the truck is traveling to the left, which means its initial velocity is negative. Both the vehicles are moving at the speed of 21 meter per second. So this gives us the value of u1 and u2, although in opposite directions. And after the crash, the two vehicles skid to a halt, which means they combine together. Now let's write the equations with substitutions for the same. M1 is 1000 kilos with U1 being plus 21 plus M2 is 2000 kilos with U2 being a value of minus 21. This gives us the combined mass M1 plus M2 because they skid together into the final velocity V. Now, we know that this equation makes sense because they have told that the vehicles skid together towards, so halt. Substituting and simplifying, we get 21,000 minus 21,000, or 21 into 2000 is 42,000, is equal to M1 plus M2, that is 3,000 times V. So V will be equal to negative 21,000 divided by 3,000. This gives us the value of V to be exactly minus 7 meter per second. Now, after the crash, the two vehicles skid to a halt. Assuming the friction is the only force acting on the vehicles after the collision, how much work is done by the friction after the crash? So here, there is a problem with finding out how much work is done by friction simply because we do not know the coefficient of friction mu. Since this coefficient of friction mu is not known, we cannot use the formula friction F is equal to mu into N or R, depending on which curriculum you studied, which would be helpful in the equation. Work done equals frictional force, let's call it FR, into the displacement D. And other way we can solve this is, if we notice, we know that the energy is not conserved at all during this collision, which means the total kinetic energy before the collision is obviously greater than total energy after. And that is exactly because the loss of energy is converted into work done against friction. So all we need to do here is calculate the initial kinetic energy. Calculate initial kinetic energy because we have the values of M1, M2, U1, U2. And we also need to calculate the final kinetic energy. We are able to calculate this as well simply because we have the combined mass. We also have the combined velocity here, -7 meter per second. And since kinetic energy is scalar, the plus or minus do not really make a difference. And finding the difference between these two, the initial and the final kinetic energy, gives us work done against friction. Work done against, let me clear this. Work done against friction. So you guys can mathematically calculate this and confirm. And please make sure to notice that the initial kinetic energy will be greater than the final kinetic energy because the part of the energy is lost in work being done against friction. We notice that this value will be exactly equal to minus 73,500 joules. The reason we need to emphasize on the value 500 minus, sorry, is because work done against friction is a loss of energy. To emphasize on the loss, we have to include the negative sign. So option B is the answer to our question, provided the values of mass and velocity in initial and final kinetic energy calculations are substituted correct. The values of velocity were found out using conservation of momentum. So this is the solution to our given problem. Have a great day, guys.